Assalamualaikum and hi everyone. My name is QRISTINA binti SABERI. My matrix number is 230817. As you can see here, I have already set up an X86 assembly language programming environment on my laptop. Therefore, today I am gonna demonstrate how to debug an X86 assembly program called average4.asm. First, we will start the debugger by clicking on debug. This will load the program into the debugger so we can run it instruction by instruction. Now, as you can see, the program is now pointing at the first instruction of our main function. Next, we want to see the content of the variables in memory. To show the memory window, go to debug and click on show memory. As you can see here, I already have it open. Inside the memory window, I am going to add two variables, which is data and result. Let's start with data. For data, the type is going to be W, hexadecimal, and array size 4. Next, for variable result, same as data, the type is hexadecimal, W, array size 1. Now we are done with the memory window. Now I will open the CPU register window by clicking on debug, show register, but as you can see, I already have it open also. Here you can see all the X86 registers such as EAX, ECX, EDX, and their content. Now I will step through the program one instruction at a time using debug step over. There is also another shortcut for step over, which is this button right here. Click on it. Now for the instruction subtract EAX will clear the register to 0 by subtracting EAX with EAX. Before execution, EAX contains a value which is 0x1. After it been executed, the EAX now has become 0x0. Now moving to the next line, move ECX 0x04. This will load the value 4 into the ECX register. Click on the step over. Now ECX counter has been set to 4. At the next line, move ESI 0x08. The ESI will set the register to 8. Click on the step over. Now ESI has become 0x8. Now we are entering the beginning of the loop instruction. This AW label right here is so that the instruction know where to jump back to. At line 11, decrement ESI will cause the ESI to decrease by 1. So 088 in here will change to 087 when you click on the step over. The next line will also cause the register ESI to decrease by 1. ESI will become 086, as you can see right here. At the next line, line 13, the instruction will command the CPU to calculate the memory address at the start of the data array plus the offset in ESI6 and add that value to AX. AX will went from 0x0 to 0x4000 once we click on the step over. At the next line, loop AW will decrement ECX from 4 to 3. Because ECX is not 0, the instruction will jump back to AW. The second loop iteration will begin with ECX 083. Same as the first loop, decrement ESI will change 0x6 to 0x5. Decrement ESI again, and now ESI becomes 0x4. Line 13 instruction will add the word at the new offset at offset 4, the memory contains 0x3000. This value is added to EAX. Now it becomes 0x7000 the next instruction will decrement ECX from 3 to 2, and again we'll jump back to label AW to do another loop. The third loop iteration starts with ECX equal to 2. Click on the step over, ESI becomes 0x3. Click on the step over, ESI now becomes 0x2. This line right here, line 13, the instruction will add 0x2000 to EAX. Click on the step over. Now it becomes 0x9000. Another decrement happened at ECX when we click on the step over, and it becomes 0x1. Now we will again do another loop. Now for the fourth and final loop iteration, we will begin with ECX 0x1. Click on the step over, ESI now becomes 0x1. Click on step over, ESI becomes 0x0. In line instruction 13, now it will read from the very start of the data array, offset 0 getting first value 0x1000. Click on the step over, it will add EAX value 0x9000 with 0x1000, produce the final sum of 0A000. This instruction right here will also decrement ECX with 1. So ECX will went from 0x1 to 0x0 when we click on the step over. ECX has finally reached 0, so the loop instruction has stopped and it went to the next line to execute the next instruction. In subtraction EDX, this will clear EDX register to 0x0. We click on step over, EDX has now become 0x0. At line 18, move CX0x04 will load value 4 into the CX register to become the divider. You can see it right here. The divider is set to calculate average. Now CX has become 0x4. The next line instruction, divide CX, will perform division. 0xa000 will now divided by 4. Click on the step over. Now EAX has become 0x2800. EDX has become 0x0. Click on the step over again. The result will be stored into memory location label result. The memory window now shows the result variable, which initially 0x00 now been updated to 0x2800. Okay, now I am going to demonstrate for the bonus part, which is print the result to the output window. Output window is right here. Before I proceed, I will stop the program first by clicking on debug and press stop. Okay, now the program has been successfully stopped. I have added two new line here. The first one is here, and the second one is right here. I already have started the debugger by clicking debug. Now we will click on step over until it reaches this new instruction right here. Okay. Now we already reached the instruction right here, right? We step over again, and the output will be shown in here. That's all from me. Thank you.